All right, let's go ahead and start then. I printed out some review problems, so let's go ahead and look at these problems. Starting with the first. And on this particular problem, it says if your car gets 24 miles per gallon. So I have a car that does 24 miles per gallon. And it says, how much does it cost to drive 300 miles, 390 miles? So we're looking at cost driving 390 miles. And then you have $3.10 per gallon. Okay, so this is basically, in this particular problem, we're looking at the cost driving 24, your car does 24 miles per gallon. You're gonna find the cost of driving 390 miles, and if the cost is $3.10 per gallon. So first thing we wanna do is, we wanna figure out how many gallons is required to drive 390 miles. So we start by writing down the number of gallons. That's equal, we're driving 390 times, oops. So that's 390 miles times. The relationship between miles and gallon is 24 miles per gallon. So basically, we need to have gallons on top, miles on the bottom, so we can cancel the miles out, and it's 1 gallon to 24 miles. So far, so good?
So far, so good.
All right. So that is going to equal to, so notice if this is over 1, so it'll be 390 times 1 over 24 times 1, which should give me, let's see, using the calculator. So we have 390 divided by 24, and we're gonna use 16.25 gallons. So this is the number of gallons used to drive 390 miles. To figure out how much these cost, we know the cost per gallon is $3.10. So cost equal 16.25 times $3.10 per gallon. So the gallon cancel out, over here is gallon. So that's gonna give me an amount of, so 16.12 times 3.10, that's gonna be $50.38. And that's the problem for the first one. Any questions?
And Woody says he's trying to get on, just so you're tracking, sir.
I'm sorry?
He says that he's trying to get on right now.
Oh, okay. Well, somebody left. Chris left anyway, so. So let's go ahead and move on to the next problem. For the next problem, it says decide which of the two given prices is a better deal and explain why. So we're looking at two items. One is sold we have shampoo. And that is 5 ounce at $2.19. And we have 14 ounces at $9.29. So we have those two particular items on sale, and we want to figure out which one is the better deal of those two particular items. In order to compare things, you must compare the same quantity to the same price. So basically, in order to figure out which one of those two is a better deal, I need to know the price per item, per ounce for each one. Okay? So starting with the first one, cost per ounce of the 5 ounce is equal. So we have the 5 ounce cost, $2.19 times we have, or divided by the number of ounces, and that should give me an amount of
Those are yours.
219 divided by 5. That's about 43.8 cents, which is about 44 cents. Yep. So 43.8, notice I changed the sign to cents instead of dollars. So it's not a dollar here, it is cents. Okay? Otherwise, it would be 0.44 cents. Dollar. Now the cost per ounce
No, we'll finish that first. And then you
of the
can have
14 ounce, that should be $9.29 divided by 14 ounce, this is a dollar.
Sir,
That
that's
should give me
it.
the cost of $66.35 or 66 cents. If we look at those two items, we notice that the 5 ounce will cost me 44 cents an ounce. The 14 ounce cost 66 cents an ounce. So that means 5 ounce is a better deal. So no matter which items you're comparing, in order to determine which one is a better deal for you, you have to find the unit price of that item. This is what we call unit price because we're trying to figure out the price for 1 ounce. Clear?
Clear.
All right. On the second question. All right, let me erase that one. Okay, on the second one, it says, your goal is to create a college fund for your child. Suppose you find a fund that offers APR of 6%. So we're looking at APR 6%. And it says, how much should you deposit monthly? So compounded monthly. It says, how much should you deposit monthly to accumulate? We're looking for $87,000 in 12 years. So basically, this is what we're looking for. We want to know how much we need to know how much we need to deposit every month at 6% compounded monthly to achieve an amount of $87,000 in 12 years. So this is a simple problem. We have to use the compounded formula. Now notice, you're looking for payment. We're looking for a monthly payment. And for the compounded formula, we have the following. The payment is equal to. Now notice, when you're looking for the compounded formulas, finding a payment, you have two options. You have one that uses a present amount. You have one that uses future amount. In this case, we wanted the $87,000 to be in the future. So therefore, we have to use the one that says the future amount, the accumulated amount. In this case, it is A times the APR over N. I'm trying to use exactly the same notation as the book, divided by parentheses. So that's gonna give me 1 plus APR over N, the power NT minus 1. Okay, this is a formula that we're gonna be using. Let me explain the formula a little bit. A will be the amount of money you want to have in the future. The APR is your interest rate written in decimal. N is the number of compounded period per year. So since we're looking at a compounded monthly, N in this case will be 12. T will be the number of years that you're gonna do this. So now, applying the information. So A is 87,000, parentheses. APR is 6%, that's 0.06 divided by 12. All of these divided by, parentheses, 1 plus 0.06 divided by 12 to the power 12 times 12 minus 1. Now, if you put in these in the calculator, the brackets indicates a parenthesis. You write it exactly the same way. Notice the exponent also must be written in parentheses. Anybody have a problem using the calculator? No?
No, sir.
All right, so once you do this problem, your amount is going to be equal to, I've done that before, it's $413.99. So basically, if you deposit $413.99 at 6% interest for 12 years, at the end of 12 years, you can end up with $87,000 in the account. Any questions?
Yeah, I'm gonna try to plug that in. So like I downloaded a scientific calculator, but I've never actually typed that type of equation in.
Okay, do you have an Excel workbook on your computer? I can
do.
show you how to put that in Excel
That would
if
be
you're
great.
interested.
Yes.
Is that a yes?
Yes, sir.
Sure? All right, we'll go ahead and do that. Okay, let me go ahead and do this. I say this is an Excel sheet. Let's use cell A, B, C, and D. In A, you can start with any amount you want, with any of these information you have. Let's say you're gonna put the A value, which is in this case, let's say 87,000. In B, we can put the interest rate, which is 0.06. In C, let's put N, in this case, which is 12. And this is N, and we have 12 years. Yes?
Yes, sir.
Okay. You pick any Excel form, any Excel cell, you write equal, and then it's going to be the payment, which is A1 asterisk, and then we have parentheses, and the annual percent is B1 divided by, and then N, which is C1, close parentheses. Then you put a division sign. Notice we have two parentheses, so I'm going to open two parentheses. In the first one, I'm going to put 1 plus, again, B1 over C1, then to the power. Of course, these are going to be this times that, C1 times D1, close parentheses again, minus 1, close parentheses. This is exactly how you're going to enter in that cell. Once you do that, then it's going to give you 413.99. In the future, all you have to do is change those numbers to the new numbers given, and that will spit out the answer for you in whichever cell you put it in.
Okay, so after the parentheses, 1 plus, right?
Mm-hmm.
Put in B1, and then what is that right there? Is that a divide?
Divide by C1,
Divide by C1, okay?
close parentheses.
And then the upward sign, right?
This one is the caret sign, and it's shift 6.
Got it. And then parentheses,
Parentheses, again, C1 times D1, close parentheses, and then minus 1, close parentheses again.
then minus 1, close parentheses,
And hit enter.
and enter. Okay, I got 41.39897.
41?
Yeah,
Okay, what do you got on A?
yeah, I got 4,700.
A1, 4,700? It's 87,000.
87,000. Got it.
Okay, and B, you got what?
0.06.
And in C, you got
C, that's 12. What is that? That's the number of,
D is the number of years,
okay?
and C is the number of compounded periods. So if it's monthly, you have a 12. If it's a quarterly, it will be 4.
Okay, got it.
All right? So that formula in an Excel sheet, you can always use it for any problem, asking for a payment, giving those information, you just type in the information and it should spit out the problem for you.
Got it.
Hey, sir.
Yes.
So one issue I was having with these, because I tried Excel as well, is some of the questions, they want you rounding to like 7 decimal places, and some they want you rounding to 6, and some it's like 4. And I noticed that would actually change my answer. It only changes it like by a penny or 2.
Correct.
But it would still change the answer. So Excel, I'm not sure how it rounds, but
Okay, if you go to Excel, if you click on between in that line over here and you extend that, it will continue with the rounding. So depending how short or how wide your column is, this is how much rounding it's going to give you.
Okay, thank you.
Okay, so if you need more rounding, if you need more number after the decimal, just extend make your column wider and it goes more. Yes? Does that answer your question?
Yes, thank you, sir.
All right. So that's, any question about this one now? We done with that? All right then, let's go ahead and erase it. Okay, another question says, it says use the appropriate compound interest formula to compute the balance in the account after the stated period of time. So you have $10,000. And it says invested for 5 years. And we have APR equal 2% compounded quarterly. Okay, for this particular problem, we're looking at how much money would be in the future if I invested $10,000 for 5 years. APR is 2% compounded quarterly. So then, again, if we look at the compounded formulas, we look at the formula that requires the accumulated amount. We have two formulas for that. One formula is P times 1 plus R over N to the power NT. And another formula contains payment in it. But this one doesn't have no payments. It's only one-time lump sum money. Yes? So in this case, we use the principal amount. This is the original amount. So in this case, P is the original amount. R is the interest rate. N is your compounded period per year. And T is how many years. So in this case, that is equal to 10,000 times 1 plus R is 2, actually 0.02 divided by, now notice, since this is quarterly, we're going to divide by 4 to the power 4 times and 5. Of course, that will also equal to, I think I have the answer over here. After 5 years, we will have $11,048.96. Yes? And also, if you want to put this in an Excel sheet, you can also, again, the same thing. This is, type it exactly in the Excel sheet as you see it. Just put star here and put the caret symbol there, those in parentheses. Okay? Is that clear?
10,000.
Okay, we're doing that. Moving on. Okay, then I'll go ahead and move on. On the second question, it says, compute the total and annual return on the described investment. It says 4 years after buying 200 shares of XYZ stock. So we have 4 years And we're doing XYZ stock for $70 a share. Says you sold at $2,200. $22,000, let's say we bought 200 shares. The question is, we want to know the total return and the annual return. Total return annual return. And it does ask for a percentage. So to figure out the total return, first we need to know the initial value of the stock. We need to know the final value of the stock. Need to subtract these and then divide by the original value. So starting with this first, original value is $200 times 70 is equal 11141. So the original value of the stock was $14,000. So we sold it at 22,200. So now we can say the total return equal 2,200. Oops. 22,200 minus 14,000 divided by 14,000 times 100%. 100% is to change that amount to a percentage. So we figured that out. And we 22,000 minus 14111 divided by 14. And that should give me 58.57%. And it says to round to one decimal, so we're rounding. 58.6%. So my total return is 58.6% on that amount. Now we need to figure out the annual return. And the annual return is the final amount and that's going to be total amount sold, which is 22,200 divided by 14,000 to the power 1/4. Now notice the 1/4 is how many years we had the stock minus 1, which is, should be in this case since I'm looking for percentage, let's multiply all of these times 100%. So that should give me 12.22%. So the annual return on the stock was 12.22% or 12.2, depending on how much you're going to round it. And that should give you the answer for that. Any questions?
Yeah, I do. So after total return, right? Where you get 58.6, right?
Correct.
you talk the rest of it again one more time because I got a little bit lost right there.
Okay, to figure out the annual return,
Okay.
we're gonna take the final price, divide
Right.
that by the original price, okay? To the power, all of these to the power, 1 over the number of years in which the stock was held by, the share were held, yes?
Yeah.
So it says after 4 years after that, right? After you get that number, you subtract 1 from it,
Subtract 1 from it, right?
and then you get the answer for those. You multiply your answer by 100,
Multiply by 100.
and that should give you about 12.22 or 12.216, what have you.
Got it. So when plugging that into the calculator, right?
Mhm.
Cell, that 1 over 4. How are we plugging that in?
Just make it to the power 1 over 4.
Okay, so we can do that on the calculator, right?
Yes,
That one in the Excel,
So
or
that-
in Excel.
both. In Excel or the calculator, you can just say to the power. If you use an Excel, I
Yeah,
think some calculator use the same thing. If you use an Excel, you use that one. And some calculator have something like that, XY, or it has this one. So if yours has this one, you click that one. If it has this one, you click that one. However, when you type XY, you have to put in parentheses 1 divided by 4. So the 1 divided by 4 must be in parentheses.
Got it.
Okay?
Thank you.
Does that answer the question?
Yes, sir.
All right. Some of the questions you have, we have simple problems as far as solving equations. So an example of those problems that in there, say you have 3x minus 16 equal to negative 10. To solve this equation, we need to isolate the variable. We have to have the variable on one side, everything on the other on the other side. Notice that the 16 is negative, and when I move it to the other side, it changes its sign. It becomes positive. So my next step is 3x equal minus 10 plus 16. So now I'm going to simplify these. 3x equal minus 10 plus 16 is 6. So then to figure out what x is, we divide by 3. Then 3 and 3 cancels, that leave me with x equal 2. Okay. So this is one of the solving problem equation that you may have on the test. You want to consider that and look at it. Okay?
1 second, sir. I gotta write this down. Almost there.
Any questions?
Hey, sir, I have one for you. Doing the review yesterday,
Uh-huh.
I ran into one of the questions.
Uh-huh.
I don't know if you have the sheet there with you. It was question number 30.
No, what's that question about?
It was Mitch and Bill are both 75. When Mitch is 25 years old, he began depositing $1,300 per year into a savings account.
Okay, hold on a second. Let me write it down.
All right.
So we have Mitch and Paul, right?
Yes, sir.
Okay, what did Mitch do?
It was Mitch and Bill. I'm sorry.
Yeah, it doesn't matter. Paul, Bill.
Okay.
They're the same name.
Okay, so they're both 75. Mitch is 25-year-old. He was depositing $1,300 per year
So
into a savings.
$1,300 per year.
Yeah. He made a deposit for the first 10 years,
Okay, for 10 years.
at which this point he was forced to stop making deposits.
Okay.
Okay, so however, he left his money in the account where it continued to earn interest
Okay.
for the next 40 years.
Okay.
Okay, Bill did not start saving until he was
What's the
45 years
interest
old.
rate over here?
Okay. All right, so Mitch, let's see here. Let me continue reading. Okay, so start at 30. Okay, assume that both accounts earned an average annual return of 7%.
7%. Okay.
Yeah, compounded once a year.
Okay. That's fine. Now, what happened with Pop? With
Okay,
the bill?
so, all right, so Paul, so we'll call him. Let's see here. Okay, he didn't start. Okay, so for the next 30 years, he made an annual deposit of $1,300
$1,300
for
per
30 years.
year for 13 years.
Yep, and he also got the average annual return of 7% compounded every year.
Okay. And after 13 years, he didn't make no more deposits.
No,
And this guy didn't make no more deposit.
yeah.
So what's the question?
Oh, it's 30 years, sir, not 13. For Paul, 30 years.
Okay. So what's the question? What are we looking for?
Okay, yeah. So when I was doing it, so the math wasn't adding up when I was getting the amount that was supposed to be in the accounts.
After
So,
how long?
yeah, so I was getting a lesser amount than what they were actually had already put into the account.
Okay. So let's figure out. So this guy went $1,300 per year for 10 years. Yes?
Yes.
After 10 years, he stopped making payment, but he left the money in the account for another 40 years.
Yes.
Okay. Let me figure out what's going on with this guy. So this guy has, let's see how much money he has after 10 years. Okay?
Okay.
So 10 years later, he has the following. A equal the payment, which is 1,300, times the APR, which is 0.07, divided by 1, since 1 is the number of payment, right? Compounded interest, divided by 1 plus 0.07 to the power 10. Yes? Minus 1.
Yes.
Now, I know one of you already did that on Excel sheet, right?
Yeah.
All right. Can you put those numbers for me? In A1,
1,300
on that one, we were looking for the payment, right?
1,300 on that one?
That would be 13. The one we did on the Excel, we were looking for the payment, right? And let me figure that out. 1,300 times 0.07 divided by 1 plus 0.07 to the power 10 minus 1. Oops. Actually, I'm looking at the wrong form. let's look at the formula correctly. A equal the payment, which is 1,300 times 1 plus 0.07 to the power 10 minus 1 divided by 0.07. This is a formula that we're going to use for the future amount. So let me clear that up. 1,300 parentheses 1 plus 0.07 power 10 minus 1 equal divided, oops, clear that. So after 10 years, he will have 17,000. If everything I did correctly, 17,961.38. Okay. So this is 10 years later. Clear on that?
Yeah. Okay.
All right. Now, this money stayed in the bank at 7% interest for another what? 40 years. So final amount is equal 17961.38 times 1 plus 0.07 to the power 40. Because that money stayed in there for 40 years, correct?
Yes, sir.
So if I take that money and I multiply it by 1 plus 0.07 to the power 40, and I should get 268,000 $268,961.96. So this is how much Mitch had after 50 years, actually, you know?
40?
No.
40 or
50.
60.
Yeah,
Well, you
50.
said you have them for 40 years after the 10 years.
Yeah, you're correct. You're correct. 50.
Okay. So now for Paul, he only deposited money for 30 years, right?
Yes.
So we do the same thing over here, but we change the 10 to 30. Okay.
Okay, tracking.
And then after 30, there is another 20 years that the amount of the money stayed in the bank for nothing. So you change that number. Whatever number you get from the 30, you put it here, and then you change that to 20.
Okay. Yeah, that simplifies it.
So that gives you how much money each one has in the account after that after that period.
Okay. All right. Thank you, sir. I got it.
No problem. Okay, let's move on to another problem. Okay, for the next problem, it says, calculate the amount of money you will have at the end of the indicated time period, assuming that you earn simple interest. It says you deposit $3,200 in an account, and interest rate is 4.3% for 10 years. Okay, so we need to figure out how much money we have after 10 years. Well, since this is a simple interest, notice you only earn interest on the $3,200. Next year, you still earn interest on this $3,200. So every year, you're getting exactly the same interest. So let's go ahead and do that. So let's figure out how much interest you're gonna get after 1 year. So interest after 1 year equal the amount of money deposited, 3,200, times the interest rate, 0.043. And that's going to equal to $137.06 and 60 cents. So this is how much money you get interest 1 year later. Interest in 10 years equal 137.6 times 10 equal 1376. So that's how much interest you're gonna get after 10 years. Total amount is equal to the original plus the interest, and that's gonna be 45.76. So 10 years later, you get $4,576 in the account. Clear?
And that was for simple interest, sir?
That's the simple interest. Remember, in simple interest, you get interest exactly the same amount every year because you only get interest on the original amount.
On the principal, okay,
Right.
thanks.
In the compounded interest, every year it changes. Clear? Okay. The next problem. For the next problem, says find the saving plan after 12 months. So we have 12 months. With the APR of 4%. And we're looking at $150 monthly. Okay? Monthly. So to figure out how much you can have after 12 months, again, we have a payment, a monthly payment, we have a period of time, we have interest rate, we're looking for the future amount. So A equal the payment times 1 plus R over N power NT minus 1 divided by R over N. So that's equal. In this case, the payment is 150 a month. So that's 150. 1 plus R is 4%, that's 0.04. N is, again, since this is monthly, so we're looking at 12. Now notice, NT is how many months in this case? Well, we already know it's 12 months, right? To the power 12 minus 1 over 0.04 over 12. So that should give me an amount of, and I also did that, 1833.33. Any question on that? No questions?
So the bottom number is the APR over the
N, which is a number of
times
compounded
something.
period. Since we're looking at monthly period, so n will be 12. Of course, n changes depending on how often you compound the money. If you compound the money again weekly, then n will be 52. If you compound it daily, then n will be 365, unless they tell you otherwise. If we're looking at, say, quarterly, then n will be 4. Okay. So here we have, remember, 12 months is 1 year. That's why I only put 12 of them. Because 12 times 1 is 12. Okay?
Okay, sir. Thanks.
Any other questions? Okay, let's move on to the next one. The next one is Sid needs 0.7 meter of canvas material to make a carry-all bag for his wheelchair. It says canvas is $9.31 per meter. So we have $9.31 per meter. It says how much will Sid spend? So how much? 0.7 meter cost. Yes? So that's a simple and straightforward. We know the cost per meter. We know how many meters we want. We just simply multiply the quantities. So we have 0.7 meter times the fraction, meter on the bottom, dollar on top, and that's going to be 9.31 to 1. These cancels out. We should end up with number of meters. And in this case, the answer is $6.52. So if Sid wants 0.7 meter, it will cost him $6.52 for that. Now remember, every time you're talking about money, you want to round your answer to two decimal places, whether they say or not. Okay? Any question on that one? Okay. One easy question probably on the test says convert the following to decimal. So how do I convert it to decimal? Just go ahead and divide. So 2 divided by 5 is 0.4. So that's converting it to decimal. And it also said convert it to percent. After I divide, I move the decimal 2 spaces to the right, and that should give me 40%. So this is a question, simple and easy on the test, hopefully to give you some points. So that's 5 given away points. Any question on those? No? All right, let's continue. Okay, on number 12, it says how much should you deposit today? In order, the question specified how much money we're going to deposit today. So we're looking at the original amount. So we're looking for a principal amount. So we don't know what that is. What's the conditions? It says, in order to have $65,000 in 5 years. So we need $65,000. Since this money, I wanted to have it in the future, so this is how much I need to accumulate. for 5 years, time is 5 years. To make a down payment on the house. Says an account with annual compounding and an APR of 7%. So we have APR equals 7% compounded annually. So this problem is simple and easy. We're given the future amount, we're given the time period, we're given the compounded interest, we're looking for the present value. So the formula for that is present value equal the future value, or let me use A instead of F. It's gonna be A divided by 1 plus R over N to the power N T. So what do we need? We need to have $65,000, so that's 65,000 divided by 1 plus R is 7%, 0.07 divided by N. Again, we're looking at annual compounding. In this case, N is equal to 1 to the power N times T will be simply 5. So that's equal to, and let me pull out the calculator, figure out that number. So it'll be 65 divided by 1 plus 0.07 to the power 5. That'll be $46,344. And 10 cents. So this is basically how much we need to deposit today at 7% interest. So 5 years later, we will have $65,000. Any question? No? Unless you guys run away, you can say yes or no.
No,
Yeah,
sir.
no,
Okay.
I was just making sure I put in the formula into Word.
Okay. So let's move on to the next one. It says someone wants to accumulate $45,000 for college fund. Again, now this one is different. This one we were looking for the present value. We know we already know how much we want to accumulate. And this one, let's see what it is. It says we want to accumulate $45,000. So let's do some changes. So if I wanted to have $45,000, that means A would be $45,000. It says for the college funds over the next 15 years. So we have a time limit of 15 years. It says determine whether the following investment plan will allow the person to reach the goal. Assume the compounding and payment period are the same. Say if a person deposited, so this is what we want, but the person is going to deposit a payment of $125 a month and APR equal 8%. Okay? Now, here is a question. We're interested in having this in 15 years, so we can have that for a college fund. Someone said, well, if you deposit $125 every month for 15 years at 8%, you should have that amount. We want to make sure this is false, true, or false. Again, in order to make sure, I want to see how much this would give me in 15 years. So to figure out the amount in 15 years, let's go ahead and use a formula. A equal the payment, this would give him payment, times 1 plus R over N T minus 1 divided by R over N. So now, let's put the amount. We know the payment is 125, so he's gonna pay 125 times 1 plus R is 8%, 0.08 divided by N. We're saying the monthly payment, so it is 12 months in a year to the power NT. That's 12 times 15. And all of these, minus 1 divided by 0.08 divided by 12. So that should equal to, after we do this, we end up with an amount of, let me see what I got here, $43,254. And 78 cents. So we can see that making this deposit every month at 8% compounded monthly is going to give me $43,254.78, which is not enough to cover 45 tests. Yes? So this particular investment or this particular plan is not going to cover that amount. We clear? All right. Moving on. Next question. For the next question, we have simplify 2 to the power 13 divided by 2 to the power 8. Notice the bases are the same, and I'm dividing, so I'm going to subtract the exponent. It's going to be 2 to the power 13 minus 8, 2 to the power 5, and 2 to the power 5 is, if I take 2 and multiply it by itself 5 times, I'm going to end up with 32. Yes? So that's also a question on the test. Moving on. Any questions?
No, sir.
All right, moving on. Only 5 more on my hand. Actually 6. It says at age 19, someone sets an IRA, individual retirement account, with APR 7%. So we have APR equals 7%. At the end of each month, he deposited $40. So payment equal $40 monthly. It says how much will the IRA contain when he retires at 65 years of age. So today he's 19 and he wants to retire at 65. Yes? So how do I figure that out? So if he's 19, he wants to retire at 65, how many years he's going to make deposits? So number of years would be what?
46.
55 minus 19, and that's equal to
46.
46. So he's gonna be making deposits for 46 years. Yes? So he's making how much? $40 a month. So we need to figure out the A equal your payment times 1 plus 0.07 divided by 12. 46 times 12 minus 1 divided by 0.07 divided by 12. Let me just put 40 over here. All right, let me see what that number comes out to be. Minus 1 divided by minus 7 divided by 12. That'll be 163,166 and 17 cents. So this person, if he's saving $40 every month in his saving account or in his IRA account, after he's 65, he will have that much money in the account with that. It says, another question in there, it says, what is the total deposits made over the years? So how much money did he make out of his own pocket? To figure out that, we know he made how much? $40 every month, yes? For how long? 46 years. And every year has how many months? 12. So basically, we multiply those together, and then we should get 40 times, I'm sorry, 46. 46 times 12, that's equal $22,080. So basically, he only made $22,080 over the 46 years, but his total amount in the bank is $163,166.17, and that's quite a lot of money, huh? Any questions? If you want to figure out the interest, how much he got interest, you just subtract those two amounts, and you will get how much interest he has collected over the years. All right, the next. It says, the whole price of a TV is 40% less than the retail price. So we have whole price, 40% less than retail price. It says in there, therefore, the whole price is blank times retail price. So we're supposed to figure out the blank. Fill in the blank. Now I need to know, what do I need to multiply the retail price by to get the wholesale price? Yes? Now let's think about this. Since I'm comparing the whole price to retail price, let's consider that 100%. Yes? Discount on that, or basically the whole price is 40% of that, less. So that means if I take away 40% of that, so 100% minus the 40% give me 60%. And therefore the whole price is 0.6, because we're gonna use the decimal notation. If I take 0.6 times the retail price, that'll give me whatever the whole price is. We clear on that? So next one. It says, find the annual percentage yield in the following situation. A bank offers you an APR of 5.8 compounded daily. Yes? So we need to figure out what's the annual percentage yield. So this is your APR. I don't know if any of you have a credit card that sometimes they give you an offer on a credit card, let's say 4.9%. But when you look at the statement, even though it says APR 4.9%, the APY may change. So how do I figure out the APY from that? Well, it's simple. So APY equal 1 plus APR over n power n minus 1. So this is basically what we do. So that's equal to 1 plus 0.058 divided by, now notice, and we're compounding it daily. Does it say how many days a year? No, so we're gonna say it's a 365 to the power 365 minus 1. And if we do that, see 1 plus 1058 divided by 365 to the power 365 equal minus 1. That's equal 0.0597, which is equivalent to 5.97%. So even though it is 5.8%, but because it's compounded daily, it becomes 5.97% compounded yearly.
Sorry, is there
Hmm?
is there a reason why there's a bracket and then a,
No, they're the same. Bracket and parentheses should be the same. I started to put bracket, but I noticed I didn't need it, so I end up putting it.
got it.
Okay, any questions? No?
No, sir.
All right, let's move on. It says you wanted to buy a car in 4 years and expect the car to cost $9,000. So 4 years. Car cost $9,000. It says your bank offer a plan with a guarantee APR. So you have APR 4.5%. Says if you make a regular monthly deposit. Question is, how much should you deposit each month to end up with $9,000 in 4 years? So basically, this is a problem we did similar to it. So we're looking at the payment is equal to, and now notice, I want $9,000 in 4 years. So the payment is going to equal to the amount times the APR over N divided by 1 plus APR over N to the power N T minus 1. Okay? So if I go ahead and do that, in this case we have A is equal to 9,000 times 0.045 divided by 12, since monthly payment, divided by 1 plus 0.045 divided by 12 divided by to the power. Now we're looking at 4 years, so that's 4 times 12 minus 1. So that should come up to be $171.48. So if I know there is a car that costs $9,000 and I have a bank that pays me 4.5%, if I make a monthly deposit, I can make $171.48 every month for 4 years. After that, I will have exactly $9,000 to purchase the car. Yes? Any questions?
So on this one, the amount is multiplied by the APR over N on the top,
Right,
like the numerator,
right.
not separate from that. Okay. I had my formula wrong on this one.
So I think we did that at the beginning of the class. We put it in the Excel sheet. Okay. Now, the next question is, it says, calculate the annual interest that you receive on the following, on the described bond. So here's what we have. We have 1,500 treasury bond. It says current yield is 2.7%, and it's quoted at 104 points. Well, in that case, this is simple. We're looking at the annual interest. So we have a bond of 1,500, since it's quoted at 104 points. So we have 1,500 times 1.04. So that's going to be the price of the, that's going to be how much the, what do you call that? The bond is. And we're getting how much interest? Times 0.027. So you multiply all of these numbers and you should end up with $42.12. So that would be the bond for this particular scenario. Any questions? No questions?
No, sir. All good.
All right, let me go ahead and do this first. And let me security restriction. Huh. Oops. Wow.